All right, hello CIS C157 students. I wanted to record a quick video tutorial for our week 4 assignment, which is asking you all to generate an 8-digit long random password. And so in this tutorial, we're going to walk through a similar application. Don't want to give away the full assignment, but we're essentially going to focus on generating a 4-digit PIN using some of the same techniques that you read about this week in your readings and that you're asked to do in the programming assignment. So by the end of this video, you should understand how to mathematically check integer lengths using a for loop, and also how to scramble a number with a pseudo-random number generator using bitwise operators, again, that you've all read about this week. So the first things first, the assignment starts talking to you all about the term seed. And in computer science, a seed is just a starting point number to be used to generate random numbers in the future. So true randomness is really hard for computers to achieve, and so we usually give them some sort of starting number or a seed, and then we run that seed through various math formulas and operations in order to scramble it and make it what we call pseudo-random, not truly random, but as close to random as computers can kind of get. And so let's go ahead and start off with this assignment. I will start by just printing a header here for the user so they know what this program's going to do. So I can do a print statement, and then we'll just format it. So 4-digit PIN generator. Okay, so just a little styling right there. And then the first thing we want to do is we want to ask the user to choose their seed, to input their seed. And so this is important because if we hard code a seed, if we pick a seed and use that every time our program runs, our random number is going to be the same every time. So really the randomness is based on choosing a different seed each time. So I'll start by declaring our seed variable, and I'll set that equal to a user input that we want to cast to an integer. And so we can do this all on one line by starting with the int function, and then inside of int, we can use our input function, and then we'll give the user a prompt. And so I'm going to ask them to enter a 3-digit starting number, which will be the seed. Okay? So your assignment also gives you some parameters on the length that the seed should be. It's going to be different than this, but you'll be able to use the same types of checks in your assignment that I use here to make sure that the user input kind of matches the parameters that we have. All right, so we need to enforce our rule, right? Our rule is that we're asking for specifically a 3-digit number, and we need a way to check to make sure the user doesn't pass in a 2-digit number or a 10-digit number, that they're actually passing in a 3-digit number. There's a lot of different ways to do this, but based on what you've all learned so far in the reading, the easiest way for us to do this is to do an if statement, and we want to ask ourselves the question, well, if the user has to pass in a 3-digit number, what is the lower bound, or kind of the lowest number that they are technically allowed to pass in? And then what's the upper bound, or the biggest number that's a 3-digit number? And if we make sure the user input falls in between those two, then we know that they're actually giving us a 3-digit number. So I'll start an if statement. So if the seed, and now I want to start with the smallest possible 3-digit number. So the smallest possible 3-digit number would be 100, right? Because if we go one lower to 99, that's not 3 digits anymore. So we know that the user's number at a minimum has to be equal to or greater than 100. So we can say if the seed is greater than or equal to 100, and then this is our lower bound. Now we also want to check the upper bound. So I can write and for another check here, the seed. Now, what's the largest 3-digit number? Well, that would have to be 999, right? Because if they go one more, that's 1,000, and that's a 4-digit number. So the seed has to be less than or equal to 999. So less than and equal to 999. If those two conditions are met, if the seed is greater than or equal to 100 and it's also less than or equal to 999, then we know that they've given us a 3-digit starting number. So we can just, for right here, print a statement, valid seed, generating PIN now, right? Something like that. You don't have to put in this print statement, but we're just putting this in kind of as a placeholder until we get to the rest of our logic. So if we use an if statement like this, I always like to write my else statement as soon as possible so I don't forget about it. So down here, let me put a comment. So this is where we have to do like generate random pin logic. We still have to code this up. But before I do that, so I don't forget, I want to put an else statement after my if, and this is if they don't pass in a 3-digit number. What do we want to do? Well, I think for now we can just print a message to the user letting them know that they need to use a 3-digit number. So we can do something like error, your seed must be, we can say exactly 3 digits long. Something like that, right? And then they'll know exactly what the error was for and they can run the program again and kind of follow the instructions. So we have our else statement. And so now we can go ahead and take a look at the actual logic we're going to use to generate this random pin for them now. So our seed is valid. We need to generate a 4-digit pin. Since we want exactly 4 digits in our pin here, we're going to have to use, or one way to do this is to use a loop that you read about in your reading this week. And the loop that I'm going to use is a for loop with the range function to specify how many times I want this loop to run, picking a random digit each time it runs. All right, so we can do for, and you can call this next variable anything you want. Sometimes you'll see it as I, which is just a standard name for a variable in a loop that you see a lot of times in programming. You could also name this something more descriptive. So for digit, since we're pulling out kind of one random digit at a time, and then in, and we're going to use our range function. And the range function just tells the for loop how many times do we want the code underneath this to run. So since we want a 4-digit pin for this example, I'm going to do for digit in range 4. And then just like our if statement, we're going to do a colon. And then down below, we're going to do the random logic, right? So I'll get rid of this comment up here. So inside of this for loop, we're going to do a bit of math here to generate a random number based on that seed they gave us. And then we're going to do that 4 different times. Each time we do this math, we're going to get 1 digit or 1 number out of it. So if we do it 4 times, at the end we'll have 4 random numbers, and that will be our random 4-digit pin. Okay, so here's where we get to some of the math. And if you look at your assignment, I provided you with some code snippets that you can use. There are a lot of different ways in computer science to generate these pseudo-random numbers. And the example that I pulled from is actually from a really, really old implementation of Microsoft's linear congruence equation in order to generate pseudo-random numbers. And so this is by no means kind of the cutting edge. I don't recommend that you would actually use this if you were really trying to generate something truly random. In fact, there are built-in libraries or modules in Python and most programming languages that we'll learn how to import in the future. They have their own random functions, which are kind of mathematically and cryptographically secure. And so in real production code, you would definitely want to use one of those. But I wanted to give you all the ability to actually utilize some of the operators that you learned about in your reading today. And so we're kind of doing this example for academic purposes only here. So the first thing, if you look at the assignment, I can actually pull that up real quick here. Let's take a look at what I'm talking about. If you scroll down to the helpful code snippets, we have a section right here called Scrambling the Seed. And the first thing we want to do, since we're starting with a 3-digit number, we want to make that number a lot bigger, right? Because the larger our number is, the easier it's going to be for us to get something random out of it versus a small 3-digit number. Or if you, I forget what your assignment's asking for, we're asking them to pass in a larger number. Yeah, so between 4 and 8 digits I had you do. So even if they passed in a large kind of 7-digit number, we still want to make it even bigger than that. And that's all this piece of code is doing here. So this is just kind of basic math. All we're doing is we're taking the number the user passed in, we're multiplying it by a large prime number, and then we're adding another large number to it, right? So we're just making it bigger. We're just expanding this seed number to be bigger. We're not doing anything kind of random yet. So I'm actually just going to copy this whole snippet out, and you can do the same for your assignment. You can change these numbers if you want. If you want to put in an extra effort and go research other math formulas to generate random seeds, you can look at that too. But if everyone wants to just copy this exact example for your code, that is perfectly fine. So I'll go back to my code now, and I am going to just paste in exactly what this is here. So again, we are taking our seed, multiplying it by a large prime number, adding another large number to it, and then we're saving those results in seed. Okay. And so what I'm going to do right now is actually, I'm going to pause and I want to print out this seed for you. So you can kind of see what's happening on each iteration of the loop, right? So our program's not done yet. Let me put a print statement there. And then in fact, I'm going to put one here too. Let me do valid seed. Okay, generating pin now. And then in fact, I'm going to just put an input statement to pause right here so you all can see what's going on. And I'll do one here as well. Okay, so you don't have to do this stuff. I'm just kind of demonstrating. I want to run the program so you can see what's happening here. So let me make my terminal a little bit bigger and then let's run this. All right, so the first thing we get, I'll zoom in. We get our header right here and it says enter a 3-digit starting number. Well, first, let's check our logic to make sure that we're actually checking for a 3-digit number. So if I put in 99, I'm going to get my print statement error. Your seed must be exactly 3 digits long. So that's good. We checked the lower range. I'll run it again and let me put in just a really big number. Same thing, error, seed must be 3 digits long. So this is a good example of how you should test your code as you write it. Even if it makes sense when you're reading it, you always want to run a test case to make sure that your code is actually doing what you think it's doing. So I just checked the 2 bounds. Let me run it again and I will put in 1, 2, 3 for my 3-digit pin and I'll hit enter. And it said, all right, valid seed of 123, generating pin now. So I'm going to press enter again. And then this is our first seed that we got after performing that math in the first loop. Now, the thing is, the next time the loop runs, and it's going to run 4 times, this is going to be the starting seed. And then it's going to do that multiplication and addition again. So our seed is going to get bigger and bigger each iteration, and it's going to change. So if I hit enter again, this is the seed the second time, the third time, and the final time. So you can see, because we're putting that seed calculation in the for loop, the seed keeps changing, it keeps getting bigger and bigger and a little bit more random every time. Okay? So you don't have to print all those out in your program. Again, you just have to print out the final kind of password for the user. I'm just doing this to demonstrate what's happening behind the scenes. And I recommend, if you're ever curious about kind of what your code is doing as you're writing it, do exactly what I did and just start putting in some print, or we call these debug statements, throughout your code so you can see what's happening. Okay, so I'm going to get rid of that stuff. I'll get rid of this as well. All right, and let's get back to going through the code. So the next thing we have to do, we have this really large kind of seed number. We want to do even more mathematical scrambling to it, right? Multiplying it by a number and adding a number does change it, but we can do more work to make it even more random. And the way that we're going to do that is we're going to utilize a bit shift operation, which is an operation that you read about in your reading this week. So bit shifts are what are known as binary operations. They operate on the ones and zeros that are actually the only thing that a computer truly understands. So even though we're writing all of this human readable code with things like print, and we have regular strings, and we have these base 10 or kind of the regular digit numbers we're used to dealing with as kind of humans in the real world, computers don't understand any of that. And so behind the scenes, no matter what programming language you're using, when you run a Python program or any other type of program, the Python interpreter is going to take all of this and translate it into ones and zeros or binary numbers, which is the only language that a computer really speaks. And so these bitwise operators, like the XOR operator, the logical OR and AND operator, as well as the right and left shift that we're going to go over, all operate directly on those ones and zeros. And so I'll try to print stuff out and generate a couple examples for you as we go through this here. But let me show you one example. I want to show you what our seed looks like in binary form. So I'm going to actually do another print. I'm going to say base 10 seed equals the seed. And then I'm going to print binary seed equals, and there is a bin function in Python that converts any base 10 digit into a binary representation for you. So we're going to print what that looks like as well. Okay, and then I'm going to pause here. So let me run this again. I'll use the same starting seed, 1, 2, 3. Okay, so after the first round of kind of multiplication and addition, we get this number. And this, what is this? 28,854,610. That number represented in binary is this right here. The 0b that you see at the front, this is just kind of shorthand in Python that everything following it is a binary number. So really, this is the binary representation of this 28,854,000 number. They're the same thing. Their value is the same. It's just represented in binary instead of base 10, which is just the normal kind of 10-digit counting that we use. Okay, if we run it again, the seed will get bigger, the binary number will get bigger, right? We keep running it. At the end, we get a really big binary number. And so this is what we're actually using our right shift operator on. We're not right shifting the regular digits that you and I are used to seeing. We're taking this big binary number here, this slightly smaller one here, and we are going to shift where this number starts and ends. So let me copy this one so I can even demonstrate it a little bit more clearly for everyone. I just want to copy it, and I'm going to go back to the code kind of down at the bottom here and maybe a comment. I'm going to paste this binary number. Okay, so we have our binary number, and what we're doing, right, if we go back to the example in Canvas here, we can take that code snippet and use the same thing. So we'll take this whole piece of code, go back to Visual Studio Code, and we're going to run this now. So right under here, we're going to say digit equals the seed shifted by 16, and then modulo 10. I'll show you the modulo 10 in a second, but modulo 10 or percentage 10, this is essentially taking the remainder from division. And so when you do this, a mod 10, you end up with one digit from a large number. And I'll show you an example of that in a second. But for right now, I want to show you what this piece of code is actually doing on a binary number. So on this number that we have as an example right here, if we just did modulo 10, we would pull out 0, or this last digit. This upper caret right here is kind of the last digit of the number that's being pulled out by this percentage 10. When we are shifting by 16, we are actually moving over 16 characters, so 1, 4, 8, 12, 16, to right here, and then we are cutting the right side off. We're splitting these numbers to where now our binary number is this part, or the more left part of the binary number. And the reason we do that, there's kind of complex mathematical reasons for it, but generally this left side, or kind of the middle right here, which is what we're going to end up pulling. We're going to end up pulling the last digit of the left side, so this 1, 0 right here. Those numbers tend to be more random than the numbers to the very right of a number. Okay, so that's all you need to know for this point. It gets into advanced cryptography. There's no need to know that for this class, but I just wanted to explain kind of what the bit shift is doing and why we're doing it. We're taking our binary number, we're counting over 16, and then basically just chopping off and getting rid of the right half. And then our mod 10, or our percent 10, is going to pull the last digit out of this right here and return that to us. So kind of a brief explanation of what's going on. I'll see if I can demonstrate that in the code as well. So I'm going to do a couple of extra print statements that you won't have to do for your assignment, but again, I want to demonstrate what's happening here. So I'm going to print in an F string, scrambled binary, okay? And this is going to be that bin of our seed. Okay, so after we left shift the seed here. Actually, I want to put this before. Let me make this a little clearer, hopefully. So let's do seed, and then print binary seed and bin seed. Okay, and then I'll pause here. All right, so we just did the multiplication at this point, and then I want to show the human readable base 10 seed and then the binary version of that. Then we're going to do our bit shift and our modulo, and from here I want to show the scrambled seed. Let's get rid of the modulo for now. I just want to show you this operation. So let's print, and we're looking at binary now. We're going to do shifted binary, and then equals bin digit. Okay, and then we'll show the human readable too. Shifted digit equals Dutch digit, like that. Okay, that looks right so far, and then we'll pause right here. And then we're going to do our modulo operators. So we'll say digit equals digit mod 10. And so we'll print last digit and digit. And we'll pause right there. Okay, a lot of stuff. Again, this is not a requirement for your assignment. I am doing this to demonstrate so you can see in the terminal kind of what's happening as this loop is running. All you need to print, if you want, you can just print kind of one thing at the end of your assignment, and that is your scrambled 8-character password. Okay, so I just want to make that clear. All right, let's run this program. And I will start again with a seed of 1, 2, 3. Okay, so it says this is our starting seed, and this is the binary representation. Now we're going to do a bit shift. So this is the shifted binary that we got. And in fact, if you look above and I count over 16, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and we take this number right here, this number right here matches exactly with this binary number right here. So you can see we literally counted over 16 and then like chopped off the whole right half, and we just kept kind of the remaining left half, which again, this matches 110, 111, 000, 110, 111, 000. And then the base 10, or the human readable representation of that number, is 440. So when we do our modulo, we're going to be chopping off the last digit, which is just going to be a 0 here, right? So if I hit enter again, we should see last digit is 0, and this is actually the digit that's going to be returned to us as our first random digit. It's just going to be the number 0. If this runs again, we have a different seed now and a really long binary number. Okay, and this is it after we've shifted it. So it's bigger, but the same thing. This is the base 10 representation. So now when we run modulo 10, what number are we going to get? Well, it's just going to be this last digit. For us, it happens to be a 3 for my seed. So if I hit enter one more time, it should show that our extracted digit is the number 3. We'll run it one more time. Really long number now, right? Let's shift it. A little bit shorter, but still super long. And we happen to get a 3 again. Okay, and then one more time, and we get a 0. So I think our whole thing was 0, 3, 3, 0, which is random, but a lot of kind of repeats in there. Okay, so that's our random number. Okay, let's get back to the actual assignment now that I've done this little kind of educational walkthrough of what's going on behind the scenes here, really just to demonstrate how this pseudo-random number generator works. But I can delete all of this, and really we just have to copy in that digit equals seed by 16 mod 10. Okay, this is the random math that you have to do. After this, all we really have to do are some print statements to output this number. So again, there's a few different ways to do this. Once you learn about arrays or concatenating strings in Python, you could add these numbers to a running string and kind of build that out and print it at the end. But since you haven't learned that yet, instead of making you do that, I want to show you how you can use the print statement to print continuously in this loop without new lines. So if we just wrote right here in the program, kind of print digit, and I run this program with 1, 2, 3 again. Oops, let me run it one more time. Okay, so 1, 2, 3. So it prints out my 0330 pin, but this doesn't, right? These are all on different lines. This isn't how I want it to look. I really want 0 followed by a 3, and then another 0. I want this printed out all on one line as a 4-digit pin. Well, the print function actually takes extra parameters, and if we do a comma and a space here, and we type in end equals, we can specify what comes at the end of the print function. By default, it is a new line. Okay, so if I run this again with end equals, this is the symbol for new line. It's that \n. If I run it again and do 1, 2, 3, my output will look exactly the same because this is what end its value is by default. But we want to change that. We don't want a new line at the end. We actually want nothing at the end. So not even a space, just empty quotes to signify don't do anything after print. Keep the cursor right where it is after you print one digit, and then we're going to keep the cursor there basically and keep using it. So let me run this one more time. I'll use the same seed. And there we go. We got our pin there. Now I probably want to put in a little more than this. I probably want to do something like your 4-digit pin is, and then print that. Right, so the user kind of sees what's going on here. If I run it again. Ooh, that didn't work. We don't want to print that 4 times. So instead, what we can do is print it up here outside of the loop. Your 4-digit pin is, and then we can do n equals that there, and then we can print digit with end equals nothing. Let's try this one. There we go. Your 4-digit pin is 0330. I know it can be hard to see sometimes, so I'll run it one more time. Your 4-digit pin is 0330, all on one line. And what I did to get around that is notice that if I try to print text inside this loop, it's going to keep printing it. So instead, before we start the loop, I do my print statement saying your 4-digit pin is. I pass in the same end break, which is nothing, because I don't want it to create a new line, because I want the real pin to come right after this colon. And then down in the example, we're just printing the digits again with an end of nothing here. Okay. I'm going to get rid of this so it looks a little cleaner. Now, I've been using the same seed every time we run this program, 1, 2, 3, right? And you've noticed the pin is the same. That's why this is truly kind of not random. The seed determines the randomness. So if you have the same input seed, even though we're doing all that math, your output is always going to be the same, quote unquote random pin. So the only way to make this really random is to change our input seed. And so we can do that real quick. I'll just use a few numbers to show you how this is random. So let's do 345. There's my random pin. We'll do 100. There's another random pin. Let's do 999. Another one, right? So all these pins are changing every time depending on the seed. But importantly, if I use the same number, like 500, 1883. 500, 1883. 500, 1883. You get the same output. And so this is kind of one of the requirements, I'll say, for your assignment. It mentions in there that the same seed will generate the same output. And so really it's up to the user to pick a different number to make this random 4-digit pin here. Okay, and so that should be it. If I zoom out here, kind of getting rid of all the extra print statements I did, you can see it's not a very long program this week. Even though it seems a little complicated, we're doing some complicated math here. This part you can copy directly out of the assignment, and then your whole program, will probably be under 20 lines of code, depending on how much, if you print a menu or how much extra printing you do. But generally, this is the real logic of the program, this for loop, and it's only 3 lines of code. 2 lines of math, 1 line of printing, right? And the rest of it is just kind of style on your end to make the program look how you want it to look. Before we close out, let me go back to Canvas and just point out a couple differences, right? So this was very similar to your assignment. Your assignment has a couple different requirements. So instead of a 4-digit pin, it's asking for a range that it needs to be basically at least 4 digits long, but less than 8 digits long. That means between 4 and 7. I give you that hint, right? What's the smallest 4-digit number? What's the largest 7-digit number? And you can use that with your if statement to make sure the user is passing in the right number of digits. And then we go through basically the loop using the modulo operator. So once you make sure the range is right, you're going to go through. The only difference here is that we're asking for an 8-digit number. So when you do that for loop with range, you don't want to copy what I did with a range of 4. You want to make sure you're using the right range for the password length that you're trying to generate here. Again, feel free to copy paste these exact pieces of code right here for doing your random number generation. And then your output is just print the 8 digits side by side on the same line. And I give you that same hint here, how to print using end equals just two quotes with nothing in between them. All right. As always, I'm available for office hours to answer any questions if they come up. Feel free to get creative with this one too by printing a menu or changing the output. But the core requirements are just making sure that you have an 8-digit random number printed out as a password by the end of this assignment. All right. Good luck, everyone. I look forward to reading your code and happy coding.